So if we look from the 30-degree angle's point of view, the red side would be the opposite, the blue side the hypotenuse, that's the name given to the longest side, and the green side being the adjacent. And that angle can be described as three ratios: the opposite over the hypotenuse, which we call the sine of the angle, the adjacent over the hypotenuse, which we call the cosine of the angle, and the opposite over the adjacent, the tangent of the angle. Well, that's clearly an awful lot to remember. But what comes to our rescue is a mnemonic using the first letters of sine, cosine, tangent, opposite, adjacent and hypotenuse, and arranged such that it tells us exactly what the sine, cosine and tangent actually represent within a triangle. And it's this, SOHCAHTOA. So here are the three letters for sine, cosine and tangent, and here is what the sine of the angle represents. This represents the opposite over the hypotenuse. The cosine represents the adjacent over the hypotenuse, and the tangent, or the tan, represents the opposite over the adjacent. So with this mnemonic, it reminds us exactly what sine, cosine and tangent actually represent. If you look at a calculator, they're all there. And using that calculator, given that we know lengths of sides, we can calculate angles. And equally, if we know angles, we can calculate lengths of sides. That's not far away, but I need to warn you about one particular problem, and it's this. I've changed the angle to the top angle, this angle between the slopy blue line and the vertical red. And by the fact that angles in a triangle must add up to 180 degrees, this must be 60, if our other one was 30. But unfortunately, what's happened is that the opposite and adjacent have swapped round. From the 60-degree angle's point of view, the green is the opposite, and the red is now the adjacent. And I've changed round the ratios of our reds and greens and blues here, such that sine is now the opposite green divided by the hypotenuse blue, cosine the red divided by the blue, and tangent the green divided by the red. And it's because the opposites and adjacents, because we're looking from a different point, have effectively swapped over. But the one bit of good news is our SOHCAHTOA relationship remains the same. Opposites and adjacents only swap because our viewpoint is different. We're viewing from another angle's point of view.